Hello everyone. So we will continue from the division of polynomials lesson that we started last time. This lesson is one of my favorite because what we are going to do are actually transferable skills. So we are going to construct viable arguments, and we are going to do this by proving the remainder theorem. And then, knowing this theorem, we are going to build on new knowledge and on old knowledge and construct new knowledge. And this new knowledge is going to be factor theorem and some extended cases of the remainder theorem. That's in essence what we do in mathematics. We ask what if questions and we build on old knowledge. So that's what we are going to do today. Okay, so let's look at this question. Find the remainder when that polynomial is divided by x plus 2. How would I approach it? Would be doing the long division. Pause the movie and try to do it yourself. As we can see, the remainder is 15, negative 15. Oh, that was a lot of work. So let's use what we've done last time when we wrote that any polynomial can be written as divisor times the quotient plus the remainder. So in my case, okay, so I can write, starting from the operation that we've done here on the left, this statement. Now, that's very important that this statement is true for any x. Like, for example, if I can say, let x be 10. Then I have 4 times 1000 plus 100 minus 3 times 10 plus 7 equals 10 plus 2. 4 times 10 squared minus 7 times 10 plus 11 minus 15. That is going to be true, so you can check. We can take let x equal 7, for example. And when I replace, I still get a true statement. How is it going to help me? So let me rewrite the statement above as, let me call this p of x, and let me call this q of x. And I want to divide p by x plus 2. So p of x will be x plus 2 times q of x plus a remainder. Let me put it r from remainder. If my aim is to find the remainder, and I don't care about this quotient, I don't need it, is it a method to do this simply rather than doing the long division? So if I only need the remainder, and I know that this statement is true for any x, I'm thinking what x can I take so that this disappears, because I don't need it, and I just want to be left with the remainder. However, I don't know the quotient and I don't want to find it because I don't want to do the long division. So another idea can be to make this whole term disappear. So if I want this to disappear, to be left with r, I can make either q of x 0, but I don't know it, or I can make this expression 0. So I will choose x equals negative 2 to make the divisor 0. Therefore, p of negative 2 equals negative 2 plus 2 times q of negative 2 plus the remainder. So p of negative 2 equals the remainder. This tells me that if in the statement above I choose, or in p, if I choose x equals minus 2, I get the remainder. Let's see what p of negative 2 is. 4 times negative 2 cubed plus negative 2 squared minus 3 times negative 2 plus 7, which is minus 32 plus 4 plus 6 plus 7. So negative 32 plus 17, which is negative 15. Exactly the answer here above without doing the long division. So this prompts us to formulate a theorem. And the theorem will be the remainder when p of x is divided by x minus a is p of a. That's exactly what we found before. Let's attempt a proof, which is exactly what we've done before. So when p of x is divided by x minus a, I can write that p of x is x minus a times a certain quotient plus a remainder, and that's true for any x real. Therefore, I can take x equals a, again, to make this 0. So, p of a equals a minus a times q of a plus r. It doesn't matter what q of a is, because a minus a is 0, so I get p of a equals r. So the remainder is p of a. That's beautiful, right? So I don't need to do the long division. I can find the remainder immediately. This brings me to the next theorem, and the next theorem is immediately from this one, and it's called the factor theorem. I'm going to start it and you are going to continue it. X minus a is a factor of p of x when, think a bit, when p of a is 0. And prove it's immediately from what we've discussed before. If x minus a is a factor, then p of x is x minus a times q of x. And that's it, because the remainder is 0. This is true for any x real. Therefore, for x equals a, I get p of a equals a minus a times q of x, 0. Let us try to see two corollaries. A corollary is a statement that follows directly from a theorem. When a polynomial p of x is divided by ax minus b, the remainder is, try to pause the movie and think yourself. So yes, you are right. The remainder is p of b over a. And corollary 2, for any polynomial p of x, ax minus b is a factor of p of x if and only if, and you are correct, p of b over a equals 0. Now, because you know the proofs from the previous page, from the theorem, I'm sure you can get the proofs as well. And for one, I give you a hint. We start with p of x equals, when I divide by ax minus b, I get a quotient, q of x, and the remainder is r. And this is true for any x. See if you can continue it. In the next movie, we are going to take a few examples.